This is day 15 of Advent of Code 2023, and this challenge is called Lens Library. The newly focused parabolic reflector dish is sending all of the collected light to a point on the side of yet another mountain, the largest mountain on Lava Island. As you approach the mountain, you find that the light is being collected by the wall of a large facility embedded in the mountainside. You find a door under a large sign that says Lava Production Facility, and next to a smaller sign they say Danger, personal protective equipment required beyond this point. As you step inside, you're immediately greeted by a somewhat panicked reindeer wearing goggles and a loose-fitting hard hat. The reindeer leads you to a shelf of goggles and hard hats. You quickly find some that fit, and then further into the facility, at one point, you pass a button with a faint snout mark and the label, Push for Help. No wonder you were loaded into that trebuchet so quickly. You pass through a final set of doors surrounded with even more warning signs, and into what must be the room that collects all of the light from outside. As you admire the large assortment of lenses available to further focus light, the reindeer brings you a book titled Initialization Manual. Hello, the book cheerfully begins, apparently unaware of the concerned reindeer reading over your shoulder. This procedure will let you bring the lava production facility online, all without burning or melting anything unintended. Before you begin, please be prepared to use the holiday ASCII string helper algorithm, Appendix 1A. You turn to Appendix 1A, the reindeer leans closer with interest. The hash algorithm is a way to turn any string of characters into a single number in the range of 0 to 255. To run the hash algorithm on a string, start with a current value of 0, then for each character in the string, starting from the beginning, determine the ASCII code for the current character of the string, increase the current value by the ASCII code you just predetermined, set the current value to itself multiplied by 17, then set the current value to the remainder of dividing itself by 256. After following these steps for each character in the string in order, the current value is the output of the hash algorithm. So to find the result of running the hash algorithm on the string hash, start off at 0, get the ASCII code of 72, so current value plus 72, then that value is multiplied by 17 and becomes itself again, then that number becomes 200 because the remainder, as it's the remainder of this number divided by 256, and then you keep doing that until you get to the very end. So the result of running the hash algorithm on the string hash is 52. The initialization sequence, the puzzle input, is a comma-separated list of steps to start the lava production facility. Ignore new line characters when passing the initialization sequence. To verify that your hash algorithm is working, the book offers the sum of the result of running the hash algorithm on each step in the initialization sequence. So for this input, this is 30, this is 253, this is 97, this is 47, 14, and so on. In this example, the sum of these results is 1320. Unfortunately, the reindeer has stolen the page containing the expected verification number and is currently running around the facility with it excitedly. Run the hash algorithm on each step in the initialization sequence. What is the sum of the results? The initialization sequence is one long line. Be careful when copying and pasting it. So let's take a look at that input. Oof, okay, that is long. So we'll start off with this one, and we will put that here, and we will do input equals list, then for line, input, we'll do equals line dot rstrip, then dot strip split by comma. Now let's print input to see whether that works. Okay, that does good. So this sounds pretty easy. We'll do total equals 0. We'll do for value in input. We'll then do hash equals 0. Then we'll do for c in value. Hash equals, this is odd c to get the ASCII number. Odd c plus total times 17 modulus 256. And I guess to make sure it's working, we'll do value equals hash. Then we will print hash, see if that works. So that's giving 200, I don't think. Is that correct? No, 52. So odd plus total. Maybe I should just do this one line at a time. So hash plus equals odd. Hash times equals 17. Hash modulus equals 256. Okay, there we go. We got 52. Then what we need to do is total plus equals hash. Then this will be return total. And we'll remove this one. So running it on that, we get 1320. Was that correct? Yes, it is. So now we'll grab our input, paste it into here. Hopefully that is correct. skj dash. Is that the last number or thing? Good, that is. So now we'll run it. 511257. That goes here and submit. And that is part 1 complete. So now on to part 2. You convince the reindeer to bring you the page. The page confirms that your hash algorithm is working. The book goes on to describe a series of 256 boxes numbered 0 through 255. The boxes are arranged in a line starting from the point where the light enters the facility. The boxes have holes that allow light to pass from one box to the next all the way down the line. Inside each box, there are several lens slots that will keep a lens correctly positioned to focus light passing through the box. The side of each box has a panel that opens to allow you to insert or remove lenses as necessary. Along the wall, running parallel to the boxes, is a large library containing lenses organized by focal length, ranging from 1 to 9. The reindeer also brings you a small handheld label printer. The book goes on to explain how to perform each step in the initialization sequence, a process it calls the Holiday ASCII String Helper Manual Arrangement Procedure, or HashMap. Each step begins with a sequence of letters that indicates the label of the lens on which the step operates. The result of running the hash algorithm on the label indicates the correct box for that step. The label will be immediately followed by a character that indicates the operation to perform, either an equals or a dash. If the operation character is a dash, go to the relevant box and remove the lens from the given label. If it is present in the box, then move any remaining lenses as far forward in the box as they can go without changing their order. Filling any space made by removing the indicated lens. If no lens in that box has the given label, nothing happens. If the operation character is an equal sign, it will be followed by a number indicating the focal length of the lens that needs to go into the relevant box. Be sure to use the label maker to mark the lens with the label given in the beginning of the step so you can find it later. There are two possible situations. If there is already a lens in the box with the same label, replace the old lens with the new lens. Remove the old lens and put the new lens in its place, not moving the other lenses in the box. If there is not already a lens in the box with the same label, add the lens to the box immediately behind any lens already in the box. Don't move any of the other lenses when you do this. If there aren't any lenses in the box, the new lens goes all the way to the front of the box. Here is the contents of every box after each step in the example. So Rn equals 1, box 0 is this, Cm minus nothing, Qp equals 3 is that, Cm equals 2, Qp minus. I got no idea what any of this means. It's such a long explanation for something, and I just don't even understand it. So you've got numbers 1 to 9. If the operation contains a dash, go to the relevant box and remove the lens with the given label. But there's no dash on these. No number with these dashes. Why is it removing? And why is it going to box 3? If it's an equal sign, it will be followed by a number indicating the focal length of the lens that needs to go into the relevant box. Be sure to use the label maker to mark the lens with the label given in the beginning of the step so you can find later. Why are these going box 0, box 1? Like, where's it getting that number from? Where did the box number come from? Okay, the hash algorithm determined it. But then why is it only 0, 1, 3? Let's change it back to this. Print hash. Okay, is it just a label? Okay, so let's do def hash label. We'll do this. Return hash. So that's all working. Nope. Okay, so is it saying in this one, we now need to do, let's say value dot split, let's say split dash 0. Or should we split equals? Is that what it's wanting? Okay, so that's what it's doing. Okay, I think I understand now. So part 2 will do if equal in value plus equals that, else we'll do that. Let's put the print back in just so we can see. Okay, there we go, that's where the numbers are coming from. So what is it that we're doing? So we're splitting it, running the hash on it, so we don't need this total anymore. Do hash val equals 0, hash val equals these, get rid of, and keep total actually. So we need to create a dictionary. We'll do boxes equals, this will be a dictionary for the boxes I think. So what does it say? So if there's already a lens in the box with the same label, remove the old lens and place a new lens in its place. So that kind of just sounds like it don't do anything. So if there's not already a lens in the box, add the lens immediately behind any lens. Okay, so QP minus, that was just remove this. Okay, so we'll start off with dictionary. We'll do, what are the numbers that it can be? 0, 256, for box in range 256, box list, is that how you do it? Print boxes Okay, that works. Actually, so to make it so it can be retrieved more quickly, we'll then make this a dictionary as well. Because we want to use hash map for everything, and if we had as a list, it will just make things less efficient. So we'll do that, and actually I should change this part. So we'll do label operation equals split, and we'll do that here as well with minus. Then hash val equals label. I guess make sure this is also working. Print label operation. Actually, operation equals plus operation, because we're actually just splitting it away. Then bring this back here as well. Let's do that. Minus. Oh, whoops. Okay, cool. That's all good. So this is what we'll do. If operation equals double equals. So if it's an equal sign, we then do boxes. Actually, we'll change that to box. Boxes, box, label equals. Okay, I guess that's kind of where this part came. Okay, we'll change that again. We're not going to do this part. We're going to keep that as it is. And I mean, if this happens, we already know what operation it is. So this will then equal operation. Sure, we'll keep it as that. Doesn't really make sense for a variable name, but we'll just do that. I'm going to bring this back, put that there, and same thing here. And then we just do delete that, I think. If label in boxes box, we delete it. So when we do that, we'll print boxes. What does that look like? Okay, that doesn't seem right. Let's just rerun that. So 0 has RN1 CM1. Oh, that is correct. So RN1 CM2 OT7 AB5 PC6. Cool, that seems to be working. So then what do we do next with these values? It's some weird thing about the ordered number, the multiplying, then powering. Just chucking these in so we can actually look at what's going on. So box 0, okay, because it's the first item. These are values. Okay, yep. So we'll do for box in boxes, if length of boxes box equals 0, then continue. Otherwise, for value in boxes box dot values. So these are the values, but then what do we do with those values? At the end of the above example, the focusing power of each line is as follows. Oh, okay, so you're just adding them together. Total equals 0. We then do total plus equals box times value, and we just return total. Int and string. Okay, so this one needs to be changed to int here 54. That is wrong. So we will print out box and value. Box needs to be +1 in here. Box +1. Okay, maybe not. Print box value. What numbers are we getting? Okay, missing number. So box 1's correct. Item count equals 1. Item count plus equals 1. Then times item count like that. 145. Is that correct? Yes, that is correct. So we will now put in the actual input and we will run it. And is this, well, we'll first check, is that number correct? The 511, yes it is. So now let's go down here and put this number in, and that is part 2 of day 15 complete. If you like this video, make sure to like and subscribe so you can watch me complete the rest of these challenges.